All right, let's get started. GM, everybody. This is Neo again from Klaytn. Um, Obviously, today we have another developer workshop. Welcome back to the developer workshop series of KLAYMAKERS22. Up next for today, we are having Harry from Chainlink. Harry is a developer advocate manager at Chainlink. Today, we're going to have sessions as a developer workshop series, part of the developer workshop series of Klaymakers22, and that will be about the Klaytn integrations with Chainlink. Thank you very much, Harry, today for joining us to give the overview about the integrations with Klaytn via Chainlink. I'm quite sure there's a lot in your workshop that you'll be talking about and going through with the hackathon participant and how that could be useful for them when they start hacking on the Klaymakers22 and trying to include Chainlink as a tool in their implementations for their use cases. Before that, I just want to talk about that Klaymakers22 won't be a successful event without the support from the ecosystem partners. Obviously, when you see the list of the ecosystem partners of Klaytn taking part of this, it has been really tremendous that we have this support from the ecosystem partners to make this happen. And also thank you very much for DoraHacks as our exclusive partners and organizer for Klaymakers22. The hackathon will be starting, as you can see, that will be August 29, literally next week, Monday. The hackathon will be starting. That will be lasting for 5 weeks, up until the end of September. Obviously, that will be the deadline. And when you look at it, the prize pool of Klaymakers22, we talk about around 360. The 300K will be going into the 5 main tracks that is sponsored by Klaytn Foundation directly, and the other 60K, 10K per each, and that is actually from the sponsor, and they are gonna have their own sponsored challenges right here. And when you look at the 5 tracks that we mentioned, the 5 main tracks, as I explained in the previous sessions, which I'm not gonna go really deep right here in this session, is just want to talk about that. If you are really interested in having more use cases for the core protocol and having more improvement or toolings around the core protocol, Core Plus track is the one that you're gonna looking at. Metaverse and NFT, we got DAO. When I mentioned what we mentioned, the 5+ previously was the DeFi. There's so many something fine project that going with. We expect everything should be based on DeFi, but then there should be different variants going forward with different use cases depending on which area in the blockchain that you think the DeFi aspect will be coupled with. For example, with the Metaverse, you have the MetaFi, and if you have any games that you're trying to build on Web3 environment or in the blockchain environment, obviously you're looking at the GameFi. That will be something that you can look at. But when you think about that, normally it's all about building use cases, tools around the implementations that you might be having. And last but not least is the public goods that I keep mentioning in the past as well. We would like to have more social impact, like more innovations that could bring in more social impact to actually make us more quality life in the world. We think about if ones can actually make use of the technologies, makes use of the blockchain technology, and most importantly, makes use of the Klaytn ecosystem to build something truly meaningful to our lives. That will be something that you're going into the public goods, and we expect many more innovative implementations that will be coming from your end. Again, thank you very much for joining us in this developer workshop. We would love to have your submissions. We would love to have more of your use cases that will be building on Klaytn. And if you start building on it or you want to keep building on it, I think there has been a lot of opportunities for everybody, for every developers that take part in this KLAYMAKERS22 to build on Klaytn ecosystem. Great. I'm quite sure you got a lot of questions just like last time or previous sessions. If you do have any questions, feel free to scan this QR code that will be sending you to the Discord channels, the official Discord channel for KLAYMAKERS22 and for Klaytn directly. And somehow your QR code doesn't work, you can just key in the URL, at the bottom, go to the Discord channels directly and have your questions answered. All right, so I guess we're gonna get into more details about how exactly Klaytn has been integrated with Chainlink, or maybe we put it in another way, how Chainlink can actually have a easier environment for you to start building on Klaytn. So how you can use Chainlink tools on Klaytn, that will be something that you will be finding out from Harry's presentations. Over to you, Harry.
Hi everyone, welcome to the Klaymakers22 Global Hackathon. Today we're going to talk about using Chainlink services when building your hackathon project. So let's get started. I'm just going to share my screen. So my name is Harry Papakarisiou and I'm a developer advocate manager at Chainlink Labs, and we work on Chainlink, which is a decentralized Oracle network. So just a quick agenda today, we're going to introduce the concept of the Oracle problem and Chainlink. Then we're going to talk about using data feeds, VRF for randomness, and any API for API calls on Klaytn as part of your hackathon projects. So just quickly, I want to reiterate for those who don't know already that blockchains are actually what's called deterministic, which means that every single node in the chain needs to always be in complete sync with each other in terms of how it computes things. So when it's computing 1 + 1, that's just math, so it's easy. All nodes will always get the same result. But what about if you need to compute what is the weather in Seoul right now or something? Some nodes might use a different API to others, or even if they use the same API, some might get different results. So this is why we say blockchains are deterministic, because they have to always get the same result when they compute things. And in the case of things such as API calls, they might not always get that same result. So this is why we say with blockchains and smart contracts, they cannot natively make API calls, right? So this is what's called the smart contract connectivity problem, where smart contracts cannot connect to off-chain data, events, or inputs because of this deterministic property that the blockchain has, right? And it kind of limits the functions to just things that can be done on-chain in the blockchain black box. So the solution to the smart contract connectivity problem is you need what's called an oracle. So an oracle is any system or device that provides that middleware or off-chain connectivity so that a smart contract can actually reach out to something outside the blockchain and connect to it, interact with it, whether it's an API call, whether it's a web service, whether it's anything. That's what an oracle provides, that connectivity from a smart contract to anything in the off-chain world. But here's where it gets a bit interesting, because using a single centralized oracle actually creates a point of failure for your system, because you've got this highly secure blockchain on one end, but then you're triggering your data or computation from a single centralized oracle node here, right? So if you're an attacker, you're not going to try and exploit the blockchain, you're going to go after this single oracle here. So it's not an ideal solution. So how do we get around this? Well, we get around it by creating a decentralized oracle network. So instead of using one oracle, we use many oracles, and they talk together. And when it's for getting data, they get data, they aggregate it, and they basically provide a single final result that is a result of all of those oracle nodes working together. So by doing this, we extend the security and reliability properties of a blockchain and take it out to the oracle layer as well. So by combining on-chain smart contract code and these off-chain services such as oracles, we have what are called hybrid smart contracts. So a hybrid smart contract is when you combine on-chain code with any off-chain service, right? So now that you know what a hybrid smart contract is, let's look at some of the ways in which you can create hybrid smart contracts today on Klaytn. So the first use case is Chainlink data feeds on Klaytn. So if you're looking at building something in the DeFi space or GameFi, MetaFi, SocialFi, there's a decent chance that you're going to need some kind of external data or price data as some part of your project, right? Such as what is the price of Klay, what is the price of WeMix, etc. So this is what Chainlink data feeds enable you to do, right? So the way in which they work is there's basically a Chainlink Oracle network per price feed, and each of those Oracle nodes connect to multiple exchanges and data aggregators and various APIs to pull price data, and each node then aggregates the data, removes outliers, and basically creates a final result for that current price pair. And then each node then submits that price pair as a report, and then that report that contains all of the nodes prices gets submitted on chain, where it's all aggregated again, and then you have a final price, which is this is the price of this asset at this time right now across the whole market. So that's kind of how Chainlink data feeds work at a high level. And in terms of the Klaytn testnet, we have two price feeds that you can use, the Klay and the WeMix price feed, and we're going to do a demo of it right now. So the best way to use Chainlink data feeds on Klaytn is first head to docs.chain.link, that's our documentation, and click on the EVM chains link here. And then first things first, we'll choose which data feed we want to query. So in the data feeds section here, you can go to Klaytn data feeds. And if you scroll down, you can see the two data feed addresses here. So we're going to take the WeMix one. So I'm going to copy that one, and we're going to go back to the data feed section, and we're going to go to using data feeds. And if you go there, you can see here, there's a very simple Solidity template that you can use for using Chainlink data feeds. So we're going to open that up in Remix. You can use whatever ID you like, of course, but for the purposes of this demo, we'll do it in Remix. So as you can see, we're importing some Chainlink libraries here. And here in the constructor, this is where you want to specify which feed you wish to query. So we're going to paste in our copy data feed address here. And as you can see, it's very simple, just a few lines of code. Once we instantiate this, we can just call latest round data on this here, and it will literally return us all of the latest information for that price feed. But in our case, all we're interested in is the price. So I'm going to compile that, and I'm going to deploy it. I'm connected to the Klaytn testnet here, as you can see. So we're going to make sure we have the correct contract selected, and we're going to deploy. Cool. Once that's done, you can see your contract here, and we're going to just call this get latest price function here. So as you can see, we get a result here. It's $2.35. There's 18 decimals in the price feeds here, so you need to take that into account. But as you can see, with just literally a few lines of code, we're able to get high quality, reliable price data in our smart contract. So I think that's really cool. So just to reiterate, in the Chainlink docs data feed section, we have a template in using data feeds, and we have the Klaytn data feed addresses here in the Klaytn data feeds section down here. Awesome. Now that we know that, let's move on. So the next thing I want to talk about, now that we know what Chainlink data feeds are and how to use them on Klaytn, is Chainlink VRF. So randomness is actually a really important feature for various use cases, especially in things like GameFi, NFTs and things like that. But if you remember earlier, I actually explained that blockchains are deterministic, and determinism and randomness doesn't really go well together. So until recently, getting random numbers on chain has been a bit of an issue, since the previous conventional way was, if you wanted a random number, was you have to rely on on-chain things such as the hash or block difficulty, or some people use centralized APIs which can be hacked. So imagine a lottery or gaming application on blockchain that uses on-chain values to determine the winner, right? So miners can influence on-chain values to a certain degree. So this is where Chainlink VRF comes in. So Chainlink VRF offers Klaytn a fair and verifiable way of getting true randomness on chain. And the way in which it works is you as a smart contract developer, in your smart contract, you using some Chainlink libraries, you basically do a request for randomness, and then that request will eventually make its way to a Chainlink node. And a Chainlink node, in that request, you'll create what's called a seed, which is an input for pseudo randomness that contains a bunch of things such as the block hash and some other values. And then the Chainlink Oracle will then generate the random number for you, and it will then get sent back to you along with proof that the random number was actually created and derived from that initial seed, right? So this is where the magic of VRF comes in, is you get proof to say that your random number is actually random and came as a result of your seed, as opposed to some other number that the Chainlink Oracle just happened to put in because it wants to influence the smart contract or something, right? So this is where you get the provable randomness. So this opens up a huge number of use cases on Klaytn, from things such as NFTs to games, DAOs, and more. So with NFTs specifically, you can use VRF to ensure NFT traits are actually truly random, or you could use it in your minting process to ensure a fair and provable random mint is carried out. So now we know gaming and GameFi is a really big part of Klaytn, and that's why VRF and Klaytn go together so well. So by using VRF as part of your game or GameFi project, you can ensure that it has truly and verifiable randomness, right? So now that everyone knows what VRF is and what it offers for Klaytn, let's do a VRF demo. So I'm just going to close this. So going back to our docs at docs.chain.link, you'll see there is a using randomness section here. So, and VRF has literally just gone live on Klaytn, so we don't have the UI up yet, but you can do everything from your smart contract. So we're going to go to the programmatic subscription example here in the docs. So you can see there's an example here, and we're going to open that one in Remix. So this is a little bit more involved than the price feed, so we're just going to run through everything here. So first things first, you can see that we use a number of Chainlink libraries here, and we have some variables here that we're going to go through. So the VRF coordinator is a contract that sits on the network that basically acts as a middleman or middle person between your smart contract and a Chainlink node. So we need to set that value. Then we need to set the address of the link token on the network, and then we need to set the key hash. So this is basically what's called a gas lane, and it basically tells the Chainlink node to use, do we want to prioritize this transaction over others, and are we willing to pay more in the form of link for it, or do we want to just leave it as kind of like a normal priority? So I think for Klaytn, we only have one gas lane for now. And then the callback gas limit is how much gas do we want to use on the callback transaction where the randomness result is returned. And number of works is how many random numbers do we want returned. So in this example, we're just going to go with 1. So before we go into the other functions, let's set these values here. So if you go to the docs again and go to supported networks, you'll see there is a Klaytn testnet link there, and we have the link token contract here. So we're going to put that in here, and then we have the VRF coordinator contract here. So we're going to put that in here, and we have the key hash for 3000 gray, which is quite high here, and that's the only one, so we're going to put it here. Cool. So now that we've set those, let's take a look at what happens in this contract. So the way in which VRF v2 works here is you have basically a subscription manager, and then smart contracts basically get added as subscriptions. But because we're doing it all programmatically, we're going to have our deployed contract be both a subscription manager or a subscription and a consuming smart contract. So I'll explain that as we kind of walk through it. But once you deploy your contract, the coordinator and link token is set. And then the first thing we want to do is create a new subscription for our VRF to say that we want to add this smart contract as a subscription to our VRF And in our case, we're going to add our own contract to it because we're all doing it from within the same contract. And then once that's done is you need to top up that subscription with Link. So you need to pay enough Link to process the VRF transactions. So you pay for VRF in the form of Link tokens, right? So we're going to add some Link to our subscription so that we can then do a randomness request. And then once that's done, we're going to do a randomness request by calling request random words here, which will basically call this function on the coordinator, passing in a bunch of stuff. Some Link tokens will get sent as well as part of that. And then once the Chainlink node does the request for randomness, it will eventually call this fulfill random words function, which will store our random result in an array, basically. But because we're only doing one, we're just going to get one random number back. So that's pretty much it. One other thing I'll point out is you need to add the Link token to your wallet. In this case, we're using MetaMask. So what you can do is you can go to the supported networks page here that I was at before in using randomness. And if you hit this add to wallet button, it will add the Link token contract to your wallet here. And to get some Link tokens, you can head to faucets.chain.link once with your wallet connected to the Klaytn testnet. And all you need to do is paste your wallet address here, which you can get from MetaMask or whatever wallet you're using quite easily. And you can get 20 testnet Link sent to your MetaMask wallet or whatever wallet you're using that way. So now that we've set these values, I'm going to compile the smart contract and I'm going to attempt to deploy it to the Klaytn testnet. Cool, so that's done. So the next thing we're going to do is we need to add this smart contract as a consumer to our subscription. So, and to do that, we need to copy the smart contract address and we're going to call this add consumer function here. Here we go. So that's basically saying, hey, as part of this subscription, we want to add this smart contract because we're going to be doing randomness requests from it. Now we need to actually send some Link tokens to our smart contract here before we can fund our subscription. So this is where I'm going to go to the Link token on Klaytn and I'm going to send to this smart contract here. I copied the address here and we're going to send 3 Link to it. I think 3 Link is the minimum or standard amount for a VRF request on the testnet. Depending on what you're doing in your callback function, it might be a bit more. But for just normal random number requests, 3 Link should be enough. So once we've sent some Link to this contract, we actually need to top up our subscription now that we have Link to use. So we're going to call the top up subscription function here, and we're going to top it up with 3 Link, but because it's in way, the figure, I like to use ETH converter here to do this. We're going to send 3, we want to top it up with 3 Link. So there's the function call there, as you can see. And now that it's topped up, we should be able to do a request for randomness. So I'm going to call request random number here. Confirm that. Cool, so that's done. We should have a request ID here. And we're going to wait just a few seconds. So that's going to send all the details to the VRF coordinator contract on the Klaytn testnet. That will send the request to the Chainlink node. The Chainlink node will, VRF node will receive the request. It will generate a random number. It will create the proof to show that it's based on the seed that it was given. And it will send the result back to the VRF coordinator. And the VRF coordinator should then check the proof to make sure it's all good. And then it should send the random number result back here on chain. So like I said before, we store it we store the random number results in an array here, but because we're only requesting one random number, we should only get one value populated into the array. So I'm going to just check the first value of the array here. And as you can see, we have a random number now on chain in our smart contract that you can use in your game or GameFi or whatever application you're building. And the random number is provably random. So there you go. Everything you need, just to quickly again, is in the using randomness section of the docs. The demo template program is in the programmatic subscription example here, and all the details for Klaytn testnet is in the supported networks section down here. Awesome, let's move on. So finally, let's talk about the third use case of Chainlink services on Klaytn now, and that is API calls. So API calls is the OG functionality of an Oracle and Oracle networks like Chainlink. So this provides the ability for a smart contract to reach out and to do things such as an API call. And this obviously opens up a huge number of use cases, because with API calls and with Chainlink nodes, you essentially get all the connectivity and flexibility that a Web2 app has today. So we actually see a lot of projects in hackathons and hacker houses and things like that use the API call functionality, because you can literally connect a smart contract to anything, right? From an enterprise backend system to a game database, an IoT device, a car, you name it. If it's got an API, you can connect your Klaytn smart contract to it. So we'll do a quick demo now. I'll just quickly explain the way it works. The way it works is it's very similar to VRF, where you basically do a request. You find your contract with Link, you do a request for an API call to an Oracle, and then an Oracle will basically do that request for you and send the result back, and that result will then get posted back on chain in a separate transaction call. So for the purposes of the hackathon, we have a Chainlink node running, processing API call requests, for the Klaytn testnet. However, if your project goes to mainnet, you obviously want to look at the running your own Chainlink node section of our docs. But for now, we'll make it easy for you smart contract developers to just use our Oracle with our jobs, so that you can focus just on the important stuff, which is building your projects. Cool, so let's shut this and let's go to our docs again. So in our docs, at docs.chain.link, you'll see there's a section called connect to any API here. So in the make a get request section, we're going to go to single word response, and you can see there's an example contract here that we're going to use. So we're going to open that in Remix once again, and I'll make that a bit bigger. So once again, we're using some Chainlink libraries here, and we're storing some information here. We're setting some values here. And the way it works is there's basically two functions. There's a function to request to do the API call, and there's a function to be called when basically with the API call result is coming back on chain, it basically posts it here, right? So the API that we're going to use today here is a price data API. So as you can see, it reports a whole bunch of information about crypto. We'll change it to Clay maybe. There we go. So we want to change the URL to the KlayUSD price data. But before we do that, we need to set some values. So once again, we need to let the smart contract know what is the Chainlink token address on the network. So once again, we can get that information from the docs. So in the connect to any API section, if you go to the testnet oracles link, you should see not there. If you go down to resources, there's a link token contracts link here, and Klaytn is there, and you'll be able to find the link token address on Klaytn from there. So we're going to paste that in here. So the next two things is we need a Chainlink Oracle and a job ID. So the Chainlink Oracle, this is basically what's called an operator contract or Oracle contract. And like VRF, it's just a contract that sits in between the consuming smart contracts and the Chainlink nodes, and it provides that kind of connectivity between the two. So in our case, if you go back to the Any API section and go to testnet oracles, you'll see a Klaytn testnet link here. So you can see the Oracle address for Klaytn testnet is here. So we're going to take that and we're going to put it here. And the next thing you need is the job ID. So depending on what data your API is pulling in, there are a bunch of job IDs here that you can use. So if you're doing a HTTP GET and the result is a byte, you use this job ID. If it's a uint256, use this one, and so on. So in this example, we're going to do a HTTP GET, and the result that we're getting is volume data. So as you can see, it's a number. So we're going to use the get uint256 job ID here. So I'm going to put that in here, and the fee. So the fee for each job by default is set to 1 link. So we're going to leave that as it is. And then in our request for the API, we're going to query this API here. We're going to, once we get a result, we want to parse that result and get the volume 24-hour, which is in raw Clay USD. So raw Clay USD volume 24-hour. So this is kind of what we're trying to get here. This value here. Okay, so once we've done that, everything else can stay the same, and it will send the Chainlink. It will send the request, and then in the fulfill function, we should get the volume back, and we store it on chain in this volume variable here. So very simple example of just reaching out to a Chainlink Oracle to do an API call to get some volume data. So let's compile this one, and let's deploy it. Let's make sure we have the right contract and deploy. Cool. So once that's done, we're going to copy the contract address and we're going to fund it with 1 link, because we need 1 link, remember, to make these API calls. The Chainlink Oracle takes that as payment for doing the API call for you. So we're going to send 1 link to our deployed contract so that when we do the API call, the smart contract will basically send that 1 link as payment when it requests the API call. So now that's done, we should be able to call this request volume data function. So we're going to expand our contract here, request volume data, and confirm. So that's going to build up a Chainlink request, which contains the URL of the HTTP GET that we want to do, what path we want to traverse in the JSON response. We want to multiply the result and basically send the request to the operator contract. And then once the Oracle receives that request, it would do the API call for us and then generate a response and then send it back. And with a bit of luck, we just call the volume getter function here. And as you can see, here's the volume right now for Clay USD on this API. So we've multiplied the result, obviously. So there you have it. With just, once again, a few lines of code and using a Chainlink Oracle, you can reach out and basically make an API call. So whether it's to get external data or to do some kind of external computation or something like that, it's very easy to do with Chainlink. So once again, all the info you need is in the Connect to Any API section. The single word response example is the one we went through today, and all the information for the network specific values you need are in the testnet oracles section here. So these use our Chainlink node running on Klaytn testnet. Once again, this is great for hackathon projects because it lets you focus on building your project and not worry about infrastructure. But if you're going to mainnet, you'll want to look at the node operator section of our docs about running your own node. But yeah, that's API calls using Chainlink and Klaytn. So that's it. As we basically went over, what is Chainlink, what is the Oracle problem. We talked about Chainlink data feeds, Chainlink VRF to get randomness, and API calls. So now that you know how to use these services in your Klaytn hackathon projects, where can you go from here? So the best place to go once again is docs.chain.link at our docs, and go to the EVM chain section. Everything I just went through is there, as well as a whole bunch of other useful information. In addition to that, if you need help or you have questions, hit us up in our Discord at chain.link/Chainlink Discord. We have a bunch of technical sections there, and we're happy to answer any questions you have there. But other than that, we're really excited to be a partner for the KLAYMAKERS22 Global Hackathon, and we can't wait to see all the cool things that you build, and just, really excited. So thank you to everyone for watching this workshop, and we really just can't wait to see what everyone builds. Thank you, and best of luck.
All right. Thank you very much, Harry, for your detailed explanations on how Chainlink tools could be using on Klaytn, or how the price fit features could be applied to Klaytn via the Oracle's tools from Chainlink, and how different things could be working using Chainlink, and how they can actually, the hackathon partners or participant can actually make use of the Chainlink tools and include these two into their implementation when they go to hunt for the prices for different tracks, different main tracks, or different sponsored challenge, what we call the bounties for KLAYMAKERS22. So again, just like last time when I mentioned that, every single time, or not every single day, but at least if you want to know more information about KLAYMAKERS, the landing page from our developer hub, the Klaytn developer hub, this website, will have everything for you about how you can gather all the developer resources to kickstart it with your own use cases for KLAYMAKERS22, and how you get to the KLAYMAKERS22 Discord channel for you to get all the questions answered. The more details about the 5 tracks, as you can see, the opportunity that we keep talking about is over 1 million. That is the cash prize plus the grants opportunity, and also different incubators or investment opportunities that will be going up after the hackathon for the finalists of the hackathon, obviously. So there are different sponsored challenges, what we call the sponsor bounties, that when you submit on DoraHacks for your implementations, what we call the builder, when you submit it on DoraHacks platform. Remember, if you want your implementation to also be considered for the sponsor challenge, remember to select the respective bounties on the builder form before submitting. But obviously the detail, the nitty-gritty of this, we're gonna go through this together with everybody when you will be joining our global kickoff next Monday. All right, so I'm not gonna go through all the things, but I just wanna say that coming up, we have more developer workshop. The next one will be on August 26th. We have Tatum and BlockPi Network will be coming up to explain the sponsored challenges for KLAYMAKERS22. They will be giving the service overview about their product, and also the problem statement about the sponsored challenge, and also different technical areas or overview that is related to their use cases directly, and also related to the Klaytn ecosystem. Building on Klaytn ecosystem directly. So after that, we have different, more focused one, more technical one. As you can see, how you can start building on Klaytn ecosystem, essentially telling you how different tools that you can use right away. You can think about this as an extended versions of the get started, or this kind of introductory materials that you can look at from the the Klaytn Developer Hub. There's so many different resources that you can look at. But I think that session you will have way more information than this for you to understand how you can actually start building, how you can actually work out your first use cases on Klaytn before you actually work out your actual implementation for KLAYMAKERS22 to be submitted, to be competed with other Klaymakers. But like I said, yeah, there's a lot coming up. You got Ethereum equivalents, like the minting the NFT directly on Klaytn. Also, some more focused one like Surface Chain and CKP. How you can make use of the tools, original, like already being open source, and you can use it right away on your use cases submitted for KLAYMAKERS22. If you do have any questions, like last time, previous time, you always have questions, even not for now, you're going to have the questions when you start hacking. And we understand that. Always get to the Discord first, put your questions right there, mingle with all the fellows that you might be having on Klaymakers22, make the best use of the connections that you can make right there on the same channel, same event. I'm quite sure that maybe some kind of surprises that you didn't expect to have, because somehow you may be meeting somebody that building very similar tools, not similar, but some tools that can go hand in hand for different use cases. You never know. Just that it's all about making connections. It's all about having quality submissions from you guys. To make it from a successful solutions to be a quality services that running in the blockchain industry, and most importantly, running on the Klaytn ecosystem going forward. I guess that will be it from us. That, like I said, there will be more coming up. Stay tuned for the next one, and I will see you next time for the BlockPi and the BlockPi network and the Tatum sponsored challenges developer workshop. See you guys next time.